In this example, we are going to find the area of the region enclosed by the following two curves. We have the curve y is equal to x cubed, and we have the curve y is equal to x. The first thing that we're going to do is we're going to find the points where these two curves intersect. All we have to do is set them equal to each other. X cubed is equal to x. We need to make sure to not cancel out an x, and instead we're going to bring the x over to the left. If we cancel out an x, we lose a root. Let's now factor out an x. This gives us x squared minus 1 is equal to 0. We can factor this as x plus 1 and x minus 1. So this gives us x is equal to 0, 1, and minus 1. We need to now find the y points that correspond to these x points. So let's choose the easiest curve, and that's y is equal to x. The other one would have been fine as well. So we have y is equal to x. When x is equal to 0, we get y is equal to 0. So we have the point 0, 0. When x is equal to 1, y is equal to 1. This gives us the point 1, 1. And then when x is equal to minus 1, y is equal to minus 1. And we have the point minus 1, minus 1. Let's highlight these because these we're going to need to plot in our next step. In step 2, we are going to graph the region. Let's start by plotting these three intersection points that we just found. 0, 0 is here. Let's put 1, 1 up here to give us a little bit more space, and then we'll put minus 1 down there. Now we're going to graph our two curves. We have the curve y is equal to x, and we have the curve y is equal to x cubed. Let's graph y is equal to x first because that's easier. That's just going to be a line that passes through these 3 points. And now let's graph our cubic. Y is equal to x cubed. It bends down and then comes back up. Let's go ahead and let's label everything. Our first point of intersection was minus 1, minus 1. And then we have the origin 0, 0. And then we have the point 1, 1. Our blue line is y is equal to x, and then our red curve is y is equal to x cubed. I chose to do this problem because I wanted to show you what happens when you have two curves that are symmetric about the origin. When this happens, the area between the curves when x is negative is the same as the area between the curves when x is positive. Because of this, we can save some time and just integrate from 0 to 1 and then just double our answer. Let's now choose a formula. We need to decide if we want to integrate with respect to x or with respect to y. So let's go up to our graph and let's draw a vertical line in our pink region. Notice that we have a curve on the top and a curve on the bottom. That means we can integrate with respect to x. If we draw a horizontal line, we have one curve on the right and one curve on the left, so we could integrate with respect to y. I am going to choose to integrate with respect to x because our functions are given in terms of x. We can then write that our area is the integral from a to b, our curve on the top minus our curve on the bottom dx. Our curve on the top is y is equal to x, and our curve on the bottom is y is equal to x cubed. Now we can write down our area. We need to remember to multiply it by 2 because we're doubling it. So we have 2 times the integral from 0 to 1. The curve on the top is x minus the curve on the bottom is x cubed times dx. Now we can go ahead and integrate this. This is 2 times x squared divided by 2 minus x to the 4th divided by 4. And we're integrating this from 0 to 1. This gives us 2 times 1/2 minus 1/4 minus 0. So this is 2 times 1/4, and this gives us a value of 1/2. And this tells us that the area between these two curves is equal to 1/2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.